Hello and welcome to another video. In this video we're going to be working on merge nodes in between zeros. And in this one you're given the head of a linked list and it contains a series of numbers separated by zeros. And for every single set of numbers that separates by zeros, you want to add them up and then store them as one number and return those. So for example, you want to merge these into a 4 and you want to merge these into an 11. So your list will be 411 and you don't care about the zeros. Then here we'd have 1, then 3, then 4. And so there's kind of two ways to do this. One is to modify the input in place, and one is to make a new list. I think making a new list is very easy. It's closer to an easy problem. So we're going to talk about how to modify the input in place to get the linked list that we want so we don't have to create anything new. And then if you were asked to make a new linked list, it would be really easy. You would just make a new linked list and then you just keep adding numbers, and anytime you hit a 0, you just reset. So that one's a lot easier. So let's go through the modify in place. So here we have this example 2. Basically what we can do is we can have 2 pointers, and so one pointer will be the starting number to look at, and the list is guaranteed to have I think 3 or more, and the first is always a 0. So the first number we really care about is here. And then we're also going to create one more node that's going to be like the dummy head of the list, just so we know where to return. So we'll make this new dummy, and our second pointer will be that one. We're going to store this variable and we're going to have a pointer here. So let's do that. So let's move this a little. So we'll have another pointer over here. Okay, and basically all we need to do is just keep adding up numbers for this one ahead until we get to a 0. So we're just going to keep traversing it until we get to a 0 and get a total. So what that's going to look like is we're going to start here. We're going to have a total of 1, and now we get to a 0. And then when we get to a 0, our cumulative total that we've reached is 1, right? We're just going to keep adding up numbers. And then the second pointer is where we're going to be writing to. So anytime we reach a 0, we can just say, let's move our second pointer up and let's write down the total. So the total was 1. So we'll write down 1. Then we're going to do the same thing. We're going to keep traversing until we hit a 0. So we hit this and we hit a 0 and our cumulative total was a 3. So we're going to move this up one more and then write down 3. And then we're going to do the same thing. So we're going to traverse to have a total of 2, have a total of 4. Now we hit a 0. So our total was 4. So we're going to do the same thing, move it up, and have a 4. And then we don't have anything more to traverse because this is the last node in the list. So basically we'll just be out of bounds. So every time we hit a 0, we will just write down the total and then move this node to the next node to start traversing. And since here we're out of bounds, we're basically done. Then whenever we're done, and we're guaranteed that the node we're writing to is always going to be less than the total list, right? Because at bare minimum, the list is going to look like 0, 0, and then some value. It might be longer, but if this was the case, then we would just write the value into the first node. So we're never going to be out of bounds here. So now that we wrote down our stuff, all we have to do, now that we're done traversing, all we have to do is just take wherever we're at and make its next pointer null. And then we can just return this guy. And so that's basically all you'd have to do. And then that's basically it. So all we do is we start at the first number that we care about, and we just traverse in chunks. We keep traversing till we hit a 0, add up a cumulative total. Then once we hit a 0, let's say we hit a 0 here, we'll move this up to the next node to start traversing. Then we'll move where we're writing to up 1, and then we're going to write in the value and reset it. Finally, at the end, we're going to have this value stored in a variable, so we can just return the next pointer of this guy. So basically, what's going to happen is going to be this will have all the values, and then let's say our cut is here. Then we're just going to return this list, obviously with the right value. So I think it was 134 or something. So what it would look like is this. This would be pointed to null. This would still exist. And then we're just going to return this node over here, which is this list. That's basically it. So most of the linked list problems, there's nothing too crazy. It's just use pointers, traverse, try not to make any more nodes. You almost never have to, and know how to cut a list and know how to list reverse. And that's basically it. So let's code that up. So we're going to use the head as the current node we're traversing, and we're going to say just head. Actually, we need to first make the dummy head of the list, which is this green guy. That's going to point to the first node in the list. We need to save that. So we'll say list node, and I do this a lot in list problems. You make a dummy, and it's going to point to the head of list. So new list node. We're not going to care about the value, so we can just give it a 0. Then we're going to make a list node cur equals dummy, and cur is going to be like the current node we're writing to. So it's not going to be really the current node we're going to write into. Every time we write, we're going to move it up one, then right there. So it'll be like the node before the node we're writing to. And we'll have a total, which will be like the total of the chunk. And that's all we need. Now we need to move the head up one, because the list, remember, starts with a 0. So it's like 0, then something. So we need to start at the first actual value, which is always going to be at this location. So, and they tell you that you can't have like cumulative, you can't have multiple zeros in a row. So it's always going to be here. Okay. Now we just say while our head is not null, what we need to do here is we need to say, keep moving up the head until we hit a 0. So while, and we're guaranteed to never get out of bounds because the last node in the list is always a 0. So we can just keep moving up until we hit a 0, and we won't be out of bounds as long as we started. Like we'll either be out of bounds to start, or we'll be out of bounds, or we won't be out of bounds at all. Okay. So here we can say while head val does not equal 0. Let's just keep adding up these values. So head, or total head val, and head is the next node. So now that we hit a 0, our head node is going to be on a 0. So like it'll be here. So first what we need to do is we need to move the head up one more to start the next chunk. So we can do that. So we can say head equals head next, and that will make the head start at the next chunk. Now we need to move up our current node we're writing to, because remember our current node starts on the green, and we want to move it up to the first node to write to. So we're going to say cur equals cur next, and now we can write into this slot. So cur val equals total, and then we can reset the total. Then basically once we're done with this loop, our cur is going to point to the last node we wrote a value in. So let's say it's here. Then all we have to do is just make the cur next equal none or null, because that's the last node in our linked list that we want to return, and we want to return the next node of this dummy node that we created. So we can say cur next equals null and return dummy next. And that's why this dummy is useful, because we're going to have a pointer to the start of the list. Alternatively, you could, the other way to do it is not use this head node, like not modify this, make another variable, and then return the head. That would also be fine, because it's going to be the start of the list. We're not doing like any, all we're doing is making one cut somewhere in the list. We're not like moving any nodes around. So you can just return the head if you want to, if you didn't modify it. So either one of those is okay. And yeah, this is pretty good. So yeah, linked list problems, I would say they're some of the easiest, like linked list trees, because linked list, there's really no algorithms. It's literally just, can you traverse and can you like move your stuff correctly, and that's it. Yeah, literally all you need is to know how to reverse, and that's pretty much it. Okay, and then so time and space wise, so this is linear because we're just like going through the list once, and then space is constant because we're reusing our linked list. But yeah, I think this would be easier if you didn't modify original input, which for most linked list problems, I do modify it because I feel like that's the right thing to do. I mean, I don't know, you can just always clarify that. With most other stuff, I don't modify original input. With linked lists, I do. But it would be super easy to make a new linked list. You would just do the same thing, except instead of making this cur traverse the original list, you would just keep making a new node. So it would be like 2 lines of code different. But it would be a lot easier because you don't have to like cut the original list somewhere, and it's just like a lot easier to figure out. But yeah, regardless, this is going to be all for this one. Pretty easy one. And if you did like this one, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.